Okay, so for 18, what we're going to do is one piece at a time. Assuming for a minute that a BD is the median. Okay, we got to know the definition there. So for median, we basically connect a vertex to the midpoint of the opposite side. So, what must be true if D is the midpoint? Okay, so first, since BD is a median, there's two things we can say. D is the midpoint of AC, or probably what they're looking for is AD is congruent to CD. I'm guessing that's really what they're looking for, is that one right there. Okay. All right, if it's an altitude, let's go, that's the answer to A. If it's an altitude, then what we should have is a right angle there. Okay? So if it's an altitude, what it does is we connect the vertex to the opposite side, traveling perpendicular to that opposite side. In some cases, we'd have to extend the opposite side to hit it, but altitude, the big thing is it's going to make a right angle with the other side, or an extension of the other side. So, what's the conclusion? All right, so D hits the other side. Our conclusion then, it must be angle BDC and angle BDA are right angles. Or you could have probably gotten away with BD perpendicular to AC. Something like that. All right, perpendicular bisector. That is a little strange. Okay, so if it is the perpendicular bisector, then we have a lot of things that happened. So, I mean, there's a number of different things we can say, because it does, in fact, go through the vertex. If this is the perpendicular bisector, not only are these the same, but that's a right angle, that would force this to be an isosceles triangle as well. So, this gives us a lot more than we bargained for here, but let's keep it simple. It's going to be perpendicular and through the middle of a side. In this case, it's side AC. So let's just go with that. What is our conclusion? First, AD is congruent to CD, definition of bisector, and AD is also perpendicular. Sorry, wrong one. BD. Sorry, BD is perpendicular to AC. That's your two immediate conclusions. All right, D, if it's an angle bisector. If it's an angle bisector, then these two angles are the same. Okay? So, angle bisector, really simple. Cuts an angle in half. So, two congruent angles. So what I'm going to say is angle ABD, our conclusion is that angle ABD is going to be congruent to angle CBD. All right, I think that's it for that portion. Yes. 19 wants us to use the same picture, so let me just draw that again. I think this is, yeah, ABC, and it wants us to use that for D. And it's telling us it's the angle bisector. All right, so this right here is 2x plus 5. Ooh. All right, trying to be tricky on this one. So here's what's happening. They're telling us this whole thing is 3x plus 20, the whole angle from there to there. Okay, so that's a little bit of a trick. So what we have is, let me just pull that out because it's tricky to see. The whole angle is 3x plus 20. However, when we put in the angle bisector, only from here to here is 2x plus 5. Well, since it's the angle bisector, this and this are the same. So this is another, what I'm going to do is I'm going to put another 2x plus 5 there. So two of those 2x plus 5s is the same as the 3x plus 20. Combine like terms, and then continue with your algebra. Okay, that's going to be 1x. Okay, so x is 30. All right. Just looking. Yeah. Oh, wait a minute. Whoops. Let's subtract 10. Sorry about that. Hang on. 1 second. Let me get that out of there. That's not 30. Subtract 10. So that's x is 10. All right. And then we got to find the measure of angle CBD. CBD. Okay. So the measure of angle CBD is right now another 2x plus 5. So 2 times 10 plus 5. That's 25. Okay. So that takes care of that one. All right, so same diagram they want, but this time BD is a median. So that tells us these are the same. All right, so BD is x plus 7, 2x plus 11. Okay, looks like they want to set those equal. All right, they're giving us these other ones. They want us to classify the triangle. That makes sense. Okay, so what I'm going to do is, since it's a median, basically we're supposed to set those equal. All right, so 2x plus 11 equals 5x minus 1. Let's go ahead and quickly get your algebra done here. Make sure we don't skip any steps here. Okay, and now it wants all the sides. All right, so 2x minus 4 is one of the sides, right, for AB. So 2 times 4 minus 4 is 4. Is that right? Okay. 8 minus 4. Sure. BC is 2x minus 2. So 2 times 4 minus 2, that's 6. This is not possible. Okay. AC, if you look, it's 7x plus 10. 7 times 4 plus 10, that's 38. You can't have that. All right, something's not right here. What I mean is there's something that we haven't taught you that we've skipped over, triangle inequality. You can't have one side that's bigger than the other two added together. It won't make a triangle. Okay, so this is not a triangle. That's all we can say here. How do you classify it by its sides? I think what they're trying to find out is they're all different, so they want you to say scalene, but it really isn't a triangle. So, all right. Let's see, next one. Partition a segment, ratio of 1 to 3. Okay, 1 to 3 ratio, that's going to lead us to 4 equal parts. Let's start with AB. All right, I'm going to count that. That's, if you move up and down here, that's 8 squares. This is 4. When they say respectively, that means AB's point should be S. Okay, So if we want to take 8 divided by 4, they're going to be 2 each. Right? And we should move from A to B. Okay, so this is one part, that's 3 parts. That's where S lands. 4 equal parts, right? Move in the first one, that's where T lands. And use your straight edge here, but draw that in. Draw a segment ST. It doesn't say to locate points S and T, but yeah, if they ever ask for the coordinates, we should give those. It's over at 1, 3 for S, and T is over at 2, 1. All right. What will be the ratio of ST to BC? We haven't taught you dilations yet, but it is a dilation essentially. So if the points are in a ratio of 1 to 4, or 1 to 3, I'm sorry, then it's also going to have a ratio of the sides. ST to BC, for this, you're going to say 1 to 3 as well. Okay, it's going to keep that consistent ratio, so 1 to 3. Is ST parallel to BC and justify? What we'll do is, because we're on the graph, to justify parallel, think equal slopes. So we're going to go calculate the slopes of these. All right, first for ST. Let's just show the rise and the run, 2 over 1, and it's heading down, so we'll throw a negative. All right, B to C. Okay, so the run's 4, the rise is 8, and it's heading down as well. What we're going to do is take out, 4. So we're down to negative 2 over 1 as well. All right, so same slope shows ST parallel to BC. Okay, so that's it. All right, we're going to put this last one, I think. Yeah, I'm going to leave the constructions for its own video. So let's work on this one here. Okay, very important problem. This one's going to be on, something like this will be on the test. So really critical we look at this. Isosceles triangle, the legs are the equal sides. Okay, so those are going to be both 17, and the measure of the base, which could be different than the legs, is 12. Find the measure of the altitude that is dropped from the vertex angle to the base. Okay, so they want to know the length of that, if that's a right angle. Now, because it's isosceles, these two triangles are going to be the same. We're going to be able to prove that. And, okay, yeah, we don't have to. This is just a property of isosceles triangles. When you drop the altitude or median or whatever, these two triangles end up being the same, okay? Which means the 12 gets cut perfectly in half to 6 and 6. So we want that altitude length there. We're going to use Pythagorean theorem. 6 squared plus x squared, though, equals 17 squared. Be really careful. That's the hypotenuse. You got to put that one. It's the longest one, so you got to put that by itself. Okay. So we're just going to solve this. 254. Something doesn't seem right there, but I'll put it down. Okay. So then we're going to square root both sides. Oh, nearest tenth. Okay. Whatever the square root of 254 is, it's just under 16. So let me go get that in the calculator. Looking at the calculator, sorry, should have been 253 here. And simple mistake, but what are you going to do? Nearest tenth, we're going to round to, so it's 15.906. Tenth is one place, so we're going to go right there. Okay, that's it for this. What I'm going to do is probably just direct you for the rest of these. Okay, so S. Messina Math on YouTube. If you type in S. Messina, no space or anything, on YouTube, she's got the solutions pretty much to all these types of problems. All right, well, good luck on your test, and thanks so much.